Video coverage of the 27th JCT Traffic Signal Symposium is brought to you by Highways News, thanks to our sponsors AGD Intelligent Traffic Systems, Clearview Intelligence, PTV Group, Message Maker Displays, Smart Video and Sensing, SRL and TRL.
Hello everyone. Okay, so in this presentation, I'll be exploring the design procedure of the CYCLOPS in more detail, using real-life examples with the aim of helping traffic signal engineers, design engineers, to design, check and approve future CYCLOPS junction designs proposals. So before I get into the details, I'd just like to give you a quick run-through of today's presentation. I'll start off with the overview of CYCLOPS design technique, then I'm going to talk about initiating and how we start the design process. Then I'm going to speak about the 2D geometrical design and some of the in-house standards that we use. And then I'm going to speak about aspects of the signal design and how we approach that and some of the problems that we need to be aware of when designing. And then throughout the presentation and towards the end, I'll be providing real-life examples showcasing some of the problems that we're facing and how we overcome them. And then I'll open up to questions. So CYCLOPS is a design technique which protects cyclists by providing an external orbital cycle track, separating cyclists from general traffic in time or space at traffic signal junctions. So here's the first ever CYCLOPS that was built at Royce Road, Charlton Road, and that's built and now on Street View and Google Images, so if you'd like to check that out in your own time, feel free to do so. And you'll notice that this design actually differs from a conventional highway cross-section, whereby cyclists are usually positioned in between pedestrians and vehicle traffic. But it was discovered by colleagues at TfGM that there are many benefits in putting the cyclists on the outside of the junction, i.e. this external orbital cycle track that we've got here. And these benefits include a larger orbit radius, so you've now got more storage space for cyclists at the stop line, and the longer turning radii now allows for a more comfortable ride for cyclists. Also, pedestrians being on the inside of the junction allow crossings to be shorter or even diagonal in some instances, and therefore more direct and closer to desire lines. These short crossings help with the efficiency of the junction too, because when you introduce controlled crossings, delays inevitably cause for vehicular traffic. Paid crossing times become shorter, enabling more time to be allocated to competing traffic phases. And the cycle crossings can afford to be longer due to the higher speeds travelled by cyclists in comparison to pedestrians. The arrangement also accommodates for multiple destinations for cyclists, whereby cyclists can filter on and off the orbital cycle route safely without any signal control. And another benefit is that it can be used in various locations and is an adaptable template, so it can be used on simple junctions and also be adapted to more complex junctions. So what do we need to do to achieve the optimum layout? So firstly, the design process starts with the analysis of the existing junction operation by interrogating a turning count of the existing traffic flows and then creating a model through Linsig or equivalent. And the aim of this analysis is to identify potential deficiencies in the current layout and signal operation in order to work out the most efficient way for existing traffic movements to traverse through the junction. So ultimately, the junction design and modelling process is focused on identifying potential areas of available space that can be liberated for walking and cycling without significantly impacting the overall junction operation. So how do we achieve this? It's worth assessing the entire junction footprint up to the highway boundary with a view of maximising these walking and cycling areas. Carriageway space should be strictly limited to cater for only the swept path requirements of the permissible vehicle traffic using any given movement. And this is a key design philosophy that will ensure that the length of the pedestrian crossings and phases are minimised. So the areas of focus within this assessment are: can we reclaim any underutilised traffic lanes? Can right-turn movements be accommodated via right-turn pockets within the junction rather than additional right-turn lanes on the approach to the stop lines? Can we reduce the length of the controlled crossings, pedestrian crossings by removing islands and utilising the additional space outside the carriageway extents? And also, can we build out to at least the extent of any on-street cycle lanes and then transfer the cyclists to this external orbital cycle route, creating naturally shorter pedestrian crossings? So here you see an example which shows an existing junction and then the proposed CYCLOPS. The space here is being optimised by building out the curb lines by encompassing the on-street existing cycle lanes. The modelling also indicated that just right-turn pockets within the junction would be sufficient to accommodate the existing flows, so the right turn lane to the south has been omitted. And now the shorter pedestrian crossings are more efficient. Okay, so now on to 2D design and swept paths in particular. Segregated cycling and walking designs can be relatively space hungry, as each mode of transport is given in its own dedicated space, often within the existing footprint of a junction. So careful interrogation at the topographical survey is required in order to identify space, and sometimes this is done over numerous iterations so that the design can release the site's full potential. So this snippet here is a snippet from our in-house design standard detail, which shows examples of compound curve geometry, which help maximise the space available for pedestrians and cyclists at constrained junctions. So each corner has its own specific compound curve arrangement to suit each individual swept path. I've just highlighted 2 swept paths on the drawing, but in reality, all movements will be tracked. So what do we need to do? Firstly, determining the criteria to which the junction layout will be designed is really important, because selecting a more onerous set of standards than what's necessary might limit the availability to maximise these walking and cycling areas. For instance, the manual streets may be more appropriate for walking and cycling schemes within an urban area than the DMRB would be. And the standards outlined with the DMRB could make achieving LTM 120 core principles more problematic when working on a constrained junction. The swept path analysis should be carried out in a way which aims to maximise urban realm, footway and cycle track areas, subject to the classification of the road and the proportion and type of vehicles used in any given movement. For example, roads leading to residential areas could be tracked with a tighter turning movement and a lower clearance. And this is particularly important for maximising space on these pedestrian corner islands. So we need to ensure adequate clearance between large vehicles and the adjacent curb lines. So at TfGM, a minimum offset would apply, typically 0.5 of a metre from the chosen design vehicle. Also, using variable lane widths that accurately match the swept path of the design vehicle will help to ensure the carriageway space is limited. And then the lane widths can increase with curvature that match the swept path. Also, the use of compound curve radii has a lot of benefits. These include slowing traffic down, liberating valuable footway space, creating shorter pedestrian crossings, and also ensuring that the pole that has the right-hand push button can be safely used and located for visually impaired users. So here's another example of a compound curve radii to create an optimal solution. So the corner radii here follows the swept path precisely, making sure as much space can be given back to the required walking and cycling facilities, as well as, again, in this instance, ensuring that the right-hand push button can be safely placed and operated easily by its users. So this slide shows useful geometric design standard details used within TfGM, all of which contribute to the safety and efficiency of the design. So these standard details and the parameters specified can be viewed in more detail within the paper, but I'll just run through a couple with you now. So, for example, you've got V1, V2 on the cycle track. So V1 denotes the minimum width of a cycle track on a one-way cycle track, and then V2 specifically denotes the minimum width for a cycle track whereby a cyclist can pass another stationary cyclist that may be waiting at the stop line. We're also due to release a full CYCLOPS technical design guide, and this will feature more standard details to cover a multitude of possible scenarios associated with CYCLOPS junction designs. We also welcome your feedback on these standard details. So here's a real-life example of adhering to those standards in a particularly tricky circumstance. So the design had to avoid various manhole covers so as to not affect the cost and timescales of the works, as the owning utility companies would charge to divert their apparatus. So this chamber here, highlighted in yellow, was particularly tricky as it was directly in line with the cycle track. But during the design, the curb line was intricately designed using compared curb lines around the chamber, using whole number standard curbs, maintaining sufficient footway widths, as well as leaving enough space to fit in the transition curve for the cycle track zebra. I also just wanted to highlight how much the original curb line can change when adopting these design parameters. This yellow line highlights the original curb line on the corner radii. So designers must be prepared to forego the existing horizontal geometry of the site in order to allocate the space more usefully and sort of look at it as more of a blank canvas. So this slide illustrates some of the key traffic signal equipment design parameters that are utilised in the production of a traffic signal design, taken from another standard detail within the paper. So understanding the proposed traffic signal operation and characteristics of the associated equipment is key as part of the design process. This is really important so that you can locate traffic signal equipment appropriately and safely. So here this table shows the ideal positions of various traffic signal poles. So each type has a varying position relative to its surroundings. For example, as you can see on the drawing, say pole 5, for instance, is solely a low-level cycle pole on an island. So that has a specific distance from the carriageway curb line and an offset from the cycle track curb line. Other traffic signal elements that are important with regards to the horizontal design are cycle phases. So at TfGM, our preferred arrangement is to position the low-level cycle signals to the near side and the off side of the cycle track, creating a cycle gateway, much like traffic phases. And this arrangement also helps in the event of a lamp failure. So other things to consider in the traffic signal design, which are more related to time rather than the physical 2D geometrical design, are things such as cycle detection. So this could be in the form of subsurface loops, piezo strips, or overhead detection, and these can be placed to place advanced demands for cycle phases. So you can minimise street clutter by not requiring an additional push-button unit pole, and then the push-button unit can be placed on the most appropriate cycle signal pole and also be used as well as for a fallback in the case of a loop failure. Also, you can revert to pedestrian and cycle stage. So at a traditional junction where cyclists share the same phases as general traffic, cyclists will be disadvantaged if the junction reverts to an all red or full pedestrian stage. So with the pedestrian and cycle phases sharing the same stage in CYCLOPS arrangements, the CYCLOPS design becomes an ideal candidate for reverting back to an all red or full ped cycle stage. Also, cycle phase delays. So because cyclists travel at a higher speed than pedestrians, these can be used to extend the cycle phases beyond the end of the combined pedestrian and cycle stage. So you can enable cyclists to make right turn movements through 2 phases over 1 stage. So this slide just shows an example of how valuable space has been liberated by analysing the existing lane usage, which showed that whilst the right turn lane to the north was important from a traffic perspective, the left turn lane to the south of the junction could be omitted. Also, the council-owned grassed area to the east here has been repurposed to provide an enhanced experience for southbound cyclists. And this final example shows another particularly challenging junction from a spatial fit perspective. So the existing junction geometry that contains staggered islands and multi-phase pedestrian crossings has been rationalised with a more efficient use of the space, whilst also maintaining the capacity through the junction. So this example also shows that the CYCLOPS and the orbital cycle track can seamlessly interface with 2-way segregated cycle routes, as you can see to the north of the drawing. Thank you for your time today. Any questions?
Interesting stuff. Thanks very much there, Charles. Do you find that you said about how the cyclists go around the outside of the junction? Do people stick to it? Do the cyclists stick to their lanes and the pedestrians stick to theirs, or or are they maybe sort of still going their own way?
Yeah, obviously with the design we try and keep a level difference as well, so we try and let cyclists know where their lane is and they can use that lane and go to where they go to, and we put crossings on what we feel are desire lines so that pedestrians wouldn't feel the need to hop into the cycle track. We've also got some data being collected at the minute and drone footage on that, the first drawing that I showed you, so that's currently live, so we've got some drone footage that the findings haven't been published just yet, but that's looking at the cycle and pedestrian interaction, the movements, the compliance, any compliancy issues. So once we've got that feedback, we'll be able to see how well it's working.
Excellent. Okay, thank you. Any questions? So there, and where's the other one? There.
Hello, Chris Goff, via East Midlands. Just wondering if you ever get cyclists trying to shortcut the right turn by going the wrong way across the one-way cycle tracks?
We try and make it as intuitive as possible with the road markings and the design and layout, that they adhere to the way that they're supposed to ride. Again, we'll have to assess the detail within this drone footage to see if there's any compliance issues, but hopefully as well, once these CYCLOPS have been designed and implemented on the whole cycle network where they're joined up by cycle tracks, and the links are all finished, you'll see a more seamless route, and it'll be more easier to reach your destination and use the correct way as if you were traffic.
Okay, thank you. Where's the mic over there, please, and then we'll... And if we can have the other mic over to Mark, please.
I know your push buttons are on the poles just after the cycle stop line. Have you had any feedback regarding particularly unusual bike types, cargo bikes or recumbents, where the rider's hands are going to be slightly further back?
Yeah, we have had feedback regarding that. There's a sort of ergonomic issue whereby you can't have you need a pole so it's behind the stop line, and the push button unit is beyond the stop line, which is an inconvenience. Sometimes we're encroaching on that stop line. So I think in future designs and stuff, it'd be more, we'll look at the feedback and try and approach it whereby you're pushing the button before you actually enter the stop line, as well as the cycle detection as well that is coming into play. Hopefully the need to use that demand button becomes less frequent.
Okay, thank you.
We whiz that mic over there while Mark asks his question, please, Mark.
You said at the beginning, outside the pedestrian.
Like I was saying before, hopefully we've not got a gauge as to how much cyclists are using these junctions at the minute, so the plan is obviously we want a big surge in cycling, and we'll see how much space they need and how little they need as time goes on, but there is opportunities in that instance, so you don't have to just increase the length, as we said before in the previous slide shows that some of the cyclists stack side by side, so there's opportunity to actually widen the cycle track as well as lengthen it before they're encroaching on any other space that's another road user might use.
Behaviour. I won't answer that. Thank you.
Right. Okay, thank you.
Hi, in Cambridgeshire. You're on. We do the cycle signals a little bit differently. We're putting in band turns because, you know, when the ring is running, technically, because it's a full cycle, that cycle could turn right across all the pedestrian crossings. So we put in, we don't do a left turn band because I don't care if they just slip out left, no conflict. But we actually manage that conflict. Are you looking to manage that differently?
We can put
visited your site.
Regulatory signs upon the poles, but with the idea of the CYCLOPS where the cyclist is on the outside, if you're travelling left, you can bypass the signals and turn left, and if you're travelling right, you can go ahead. For cyclists that want to feel safe, stay within the cycle track lane and then use the appropriate crossing across the road. You'd think, hopefully, once the cycling numbers increase, a cyclist wouldn't breach the the pedestrian crossings. But yeah, if you feel the need that it's a real hazard that cyclists there's a desire line for them to turn right there and not actually use the cycle track in the two phases in one stage. Then you can put additional signage up. Yeah, well, yeah, safety's key, isn't it? So, yeah.
Obviously, we talked about sort of positives for cyclists. What effect has it had on vehicle traffic, or isn't that actually a priority anymore?
I think, obviously, the creation of CYCLOPS, one of the main benefits is its use of maintaining capacity, shortening all the crossings, trying to squeeze in the junction, bringing all the stop lines in, and trying to maintain the capacity of the junction. Obviously, we're seeing a big shift in walking and cycling and a lot of funding coming into walking and cycling, but often you do get a brief which says, yes, we'd like all the walking and cycling, but we want the capacity to remain the same, or if not better. So, as a designer, you're obviously sometimes limited in what you can do when you're introducing these control crossings, but ultimately, we've found that when we're modelling these CYCLOPS, we're managing to maintain the capacity more often than not.
Okay, excellent. Right. Any more questions? Okay.
Hello, Mark Crabtree, TRL. What is the attitude towards the more confident cyclist who's going to, particularly when you're turning right, who are going to see this scheme as disadvantaging them? Because, you know, if you're turning right, you can do it in one go from a traffic lane. But otherwise, you've got to not only go around the whole ring, you've got to give way to pedestrians and possibly cross two stop lines as well.
Yeah, so one of the primary things that we were looking at when designing these CYCLOPS is we're looking at we want the uptake of cycling. So you sort of, in some instances, designing for that 12-year-old cyclist not competent. We're sort of tackling the issues of obesity, air quality, congestion and stuff. So you want people cycling who feel comfortable, have their own lane, can use it. And when you say about the more professional cyclists, they can still maintain, get in primary position, use the junction as if they would it was a normal junction. They can still use it in that fashion, and we think that they're confident enough to use it, and they can use the traffic lanes if necessary to them.
Yeah, but I can
take
also
that risk.
I can also see if you turn right from the east here and go north, as you see on the picture. Once you've made that manoeuvre on the road, you're stuck on the road. You can't get back onto the cycle track because of the curbs there.
Yeah, so those that want to make that manoeuvre within the junction and then get back into the cycle lane, a lot of the designs that we do just after the junction, we have gaps within the segregation, so cyclists can merge back into the cycle track if they wish to do so.
Okay. And Chris Boardman obviously has gone now from Transport for Greater Manchester to Active Travel England. How much are these experiences then going through Active Travel England to then be shared and implemented elsewhere?
I think currently at TfGM we've got about 6 on the ground at the minute and around 50 in production. I think there's been a lot of appetite from other areas. Obviously, we said before Cambridge have looked at it, and Chris Boardman has left. So I think the general consensus from the sort of active travel community is that they're a success. So hopefully we'll be able to see them dotted around more around the UK and potentially internationally.
Okay. Right, do you know what? We're going to finish about a minute early, which means that by the time we go... Oh, we're not, because John's going to take over. Right, okay. Then I will finish. I'll ask you to thank all our speakers. Thank Charles and all the other speakers. Thank you.